Okay. Should be up now. Uh, we're just gonna wait a little while for people to join from the link, if that's fine with everyone.
Okay, 100%.
Okay, hi guys. We'll just wait like 2 minutes for the rest of the people to join, and then we'll start. Yeah.
I don't know when you started.
I will tell you when we're good to go. Yeah.
Right.
If you hear me
Because all I see is
talking,
myself on the screen, obviously. Right.
yeah, I know. I'm so sorry. If you hear me talking, I'm talking basically to the live stream. Yeah. Yeah. Well, if it's a bit random. Yeah.
That's fine.
Cool. I think we should be able to start now. Yeah. Okay. Hi guys. My name is Peter. I'm from Team TechSpand, South Africa, and I'm here with Derek from Robotic Handling. In the last session, we talked about Connect and why Connect is so important. So we connected with Robotic Handling. I think it was 2 years ago, and yeah, it's been a great connection. And Derek is just going to talk about his story a bit. Cool. Over to you.
Good evening, folks. Thank you for inviting me this evening to share my story. Before I get into detail about our journey with TechSpand, I'd like to give you a bit of insight into our company. I founded Robotic Handling Systems in 2009. It was more of a curiosity in terms of trying to explore the market with robotic systems, to see what possibilities we could bring to the industry. 15 years back, robotics wasn't new in the world, but it was still very fresh in South Africa. How I got to start in business in robotics. At a young age, we didn't have social media, we didn't have internet, we didn't have all these distractions that we have currently today. We had broken radios in the garages. We had devices that we could strip and play with, and so out of boredom, we would dismantle items to see how they would work. And I think from a young age, there's always been a curiosity of how to build things. My first computer was a Spectre Video 32K, so it had 32 kilobits of memory was the total memory that came with the computer. And other than playing games on it, it came with a manual, which was how to teach yourself to write basic programming. Basic was the language, and I found it quite interesting, and taught myself how to program until I ran out of memory and threw the computer in the garage. And then, along with programming, I always had a fascination for electronics. Back in the day, then to even have a binary coded decimal counter, so just 4 LEDs to counting binary, it would take us about a whole evening to build a circuit with JK flip-flops and AND gates and LM 555 timers just to be able to count to 15. So I've always had this low-end nuts and bolts curiosity with programming, microcontrollers, and building stuff. And so after joining the Air Force, because there wasn't really money to go and study, I joined the Air Force to be able to study aircraft instrumentation. And after that, because of things that changed in our country in '94, I left the Air Force and started my own electrical contracting business, and eventually joined my wife's side of the family business in brick manufacturing. And whilst working in the factory, I managed to get the opportunity to teach myself how to program in PLCs, and I started automating the big plants. They had a lot of issues with operators blocking up machines because on a Monday morning they weren't quite focused, and they would start the machines in the incorrect sequence. And by installing the PLC, I was able to give them a garage remote with 4 buttons so they could start the equipment, stop the equipment, start the clay feed, stop the clay feed. And this really drove my curiosity towards robotics, where we could further optimize the process, not to necessarily take away jobs, but to have a look at how we could make the system more consistent. Because putting clay bricks onto pallets, you want equal drying between the bricks. And we found that, by human skills, they were, packing a day and they would do it really fast. And, they would not have consistent gaps between the bricks. And so, we'd have different results in terms of the drying quality of these bricks. And so by, mechanizing the process using robots, we were able to get a much more consistent pack format, which reduced the waste of other product, making the company more profitable. So, this drove my curiosity to how we could, further utilize robotics, not to, again, replace jobs, but to make companies more sustainable or more profitable by implementing robots where, they can be more consistent and produce less waste, especially in welding applications where we can reduce splatter, we can get good penetration with welds. And so I started Robotic Alien Systems with the intention to keep myself out of trouble, but also because I was really curious about robotics. So for 15 years, we've been building all sorts of systems, from picking and placing, palletizing systems, welding systems. We've used a lot of vision systems to help assist with identifying parts, using robotics to make sure that we're collecting or picking the right part, placing in the right position. And it's been a real interesting journey, having a look back even just over the last 15 years of how technology has changed, and how the cost of technology has not necessarily risen, but what you're getting for the same amount of money, what applications we were able to do with the rapid growth in technology. So, back 10, 15 years, we were, spending quite a bit of money on vision systems, but they weren't as capable as they are today, where we can use 3D cameras to be able to do bin picking, so random picking of bins or parts in a bin. And it's fairly easy to set up, and this is really exciting when you see what's capable of with the robot. So when we were reached with the TechSpan, Greg contacted us to see how we could support or how we could share some of our knowledge with the TechSpan team. For me, it was quite exciting to be able to take some of this knowledge and know-how that we had gained as a team. I had some young engineers that joined me 12, 13 years ago, and for me, the part that makes it worth the while is not the financial part so much. It's being able to take people along with me in the company and to be able to see how they've grown, to become good engineers, and from coming freshly out of university or Technicon and having really little experience, but with time, how they've grown to be able to use their imagination and knowledge, and with the sort of tools that we've been able to purchase over years, the 3D printing, CNC machines, and using 3D software, just how the imagination and experience and how the years, how it's grown, and how they've been able to build some really awesome equipment. And for me, my philosophy has always been that we need to build equipment that's not necessarily only functional, but it's got to have a really good appeal. It's got to look good. It's we don't want to build the Uno or the Volkswagen Beetle. We wanted to build the Porsche. So we spend a lot of time in how we can make our equipment look really good, but it had to be functional and maintenance friendly. And so what I really enjoyed too was how we by providing these opportunities was to be able to afford people to use their imagination and to grow, and how they could, really build machines that are really nice to look at, but also work really well. So with our opportunity with TechSpan, first it was financial assistance, and later on with also helping with mechanical design and printing some parts and then machining some parts to be able to make the robot more reliable. And last year when we were able to offer some more financial support and to bring in some parts to be able to make the new robot more functional, we also understood just the challenge that you guys have on these first tech challenges, and just what sort of problem solving capabilities this first tech challenge offers, or at least presents to these teams. And for me, this is really important and interesting because businesses like ourselves, we need to be able to fill our incredible pipeline, and finding youngsters that are spending their spare time to find these solutions to complex challenges or problems. For me, it's hopeful in the sense that if we can try and support and feed this curiosity and show that there's a strong line from these challenges that you do now to how do we support to the going through your studies in varsity, and how we can offer employment downstream, so that we could organically grow our businesses to have these passionate people that are really doing it for the passion and not for the money. So it was a real eye opener for me, and it was a good journey and I was fortunate to be able to be drawn into this journey with TechSpan, and it was really nice to see how they flourished over the last year with and with their great achievement as becoming world champions. So as a business owner and having a look at from where I started with my interest and curiosity and aligning with generation, and I know that the challenges in today's time is that there's a lot of these distractions with social media, and we have all these YouTube online. They spend a lot of time watching rather than doing. And for me as a business owner, we always try to find people that are willing to want to get their hands dirty to actually build and try and experiment. From when I started this business, there wasn't a unique problem that we initially had to look at trying to solve. And through the years, we had some real challenges. And what I experienced and what I can take out of the last 15 years is that to be successful, one has to really be passionate. You need to have a lot of determination, but most of all, one's got to really have the perseverance. Without perseverance, if we're confronted with any technical challenge or any challenge, if one tends to give up too soon, you lose that victory after the battle, where finding that sweet solution to a technical challenge. So yeah, that's our story. And it's there's a lot of opportunity out in our industry, as we know. Technology is moving in that direction, where AI and robotics is with us for forever, I guess. And if we look at the platforms that are out there, from ROS, where I don't know if how many viewers have ventured into ROS, which is Robot Operating System, so ROS.org. You have a look at how many engineers around the world are contributing to a platform where you can use any sort of kinematic model to build these robots. And you look at the AI that's built into machine learning and Python as a platform. And if I look at what we were building when I was in school, nearly 35, 40 years ago, finding decimal counters to what you have with the Raspberry Pi now and Python language in terms of what you can do with machine learning and a simple camera, it's really exciting times. And for me to be able to support passionate youngsters that are spending their time playing with nuts and bolts in the sense of coding and how we drive servos and how we make these arms and robots work, it's a real opportunity to be able to try and share some of the knowledge gained and some of the experience, and also to offer an environment that we have in our workshop to be able to offer students that are really keen to want to explore their imagination and their curiosity to show and guide and give opportunity to grow, so that we could provide good engineers moving forward.
Yeah, thank you so much, Derek, for sharing your story and yeah, just talking about your company and your experience in the STEM field. Yeah, just thank you so much for sharing that. We do have,
Yes,
yeah,
pleasure.
yeah, thank you. Really appreciate it. We do have one question so far in the chat. If anyone has any more, you can quickly put them in the chat. But so far, the one question is, what did you study to go into this field? What did you study at university?
No, so I'm not a professional engineer. I'm a self-taught enthusiast. So I've been reading for 30 odd years of any book I could find on electronics and on machine building. I studied aircraft instrumentation because there was no money when I grew up to go to university, so I had to join the Air Force to be able to learn a trade and to study further. And yeah, did aircraft instrumentation, and then after that, I started a business in electrical contracting based on my knowledge gained through the years. And yeah, it's I didn't get the chance to go to study university, and yeah, I would in today's time. I mean, there are many great courses. A lot of interest is drawn to mechatronics. It's a subject that I'm not entirely in favor of, because it's something that goes into a lot of different disciplines. So I think it offers a little bit of mechanical, a little bit of programming, a little bit of electronics, a little bit of electrical, and so forth. I have a few mechatronics. Well, most of the students I've coming through have done mechatronics. And when I compare them to some of the engineers that I employ in mechanical engineering or disciplines where they've only studied electrical or mechanical, I find that you can see the point from when they start working to when they contribute to the company. So when they're actually able to do a certain task and complete a task, the turnaround time is quicker. I find with mechatronics, and that because it's such a vast field, and coming out of a university where you only get exposed with a certain time in each of these disciplines, for me, when we look at a system comprising of a lot of different components, from servo drives to variable speed drives for induction motors to robots, and you have PLC, and we can have different brands, PLCs, programming in different languages. Understanding the different types of communication networks, industrial networks, from Ethercat to Ethernet IP to TCP, Modbus over Ethernet. There's so many different areas that one has to understand, in terms of how do you move data between different devices, and how they need to be connected and wired, and how do we need to build a control panel, and what are good practices in terms of devices that you have. So it's a very vast field, and I think when one sort of dilutes the disciplines into a course like mechatronics, one has to just be cautious that it just takes a bit longer to be able to specialize, I would think, in a certain discipline. I'm not sure if that answers the question, or if I got a little bit sidetracked there.
That answers the question really well, thank you. And then another question that we have is, what advice do you have for students starting out in robotics?
So obviously we are more industrial robotics. So we're using 6-axis manipulators to be able to do certain functions. We're not using mobile platforms or autonomous machines at this stage. I think when one starts to look at robotics, it's there's the mechanical part, there's the electrical part, there's the programming part. So there are a lot of different areas that one can explore in robotics. A industrial robot that we would use, you wouldn't buy it with any tooling. We buy a manipulator that has a certain reach and payload, and it's either 4 or 6 axes, and we would size the robot according to the application that we're wanting to do. So I mean, sometimes we need a small robot that needs to move really fast and pick parts that are really accurate. So to understand where one can use robotics would be I mean, there are a lot of software, freely downloadable software from the likes of ABB, Fonuk, Motorman. One can download simulators. There are a lot of applications out there, like visual components, that offer where you can do a simulation in a robot, with free software. So I think if you're wanting to get into industrial robotics, is to understand how the kinematic models work, understanding how one can move a robot, understand how the links are mechanically linked together. There's a lot of wealth of information in terms of reading manuals and online content where just understanding the different components of a robot. There's obviously a lot of content out there. We do robot training courses as well, and then also, just contact companies like myself. We're always really keen. We could, through Greg at TechSpan, we were more than happy to hold sessions where we can introduce just the basics of robotics. Show how they are manipulated, show the different components, to see where your interests lie. Is it mechanical? Is it electrical? Is it programming? There's quite a bit to be involved in with robotics.
Yeah. I think that just shows that as well, that how important Connect is for like a team like ours, and just being able to connect with the industry professionals like you and all other companies. And it also just shows like how willing industrial companies are actually to help teach the new generation, and just try to pass on some of those skills. And then I think the last question.
Absolutely.
Yeah. And I think the last question that we can answer is, in the industry, is it the programming or the building more difficult?
It depends on the application. Sometimes, if we're doing a simple palletizer, when I say simple palletizer, the simple palletizer will be packing maybe 15,000 bottles of product an hour. A little more complicated would be 45,000 bottles of product an hour, where we need maybe 3 robots to pack the product onto a pallet. If we have a look at the lower volume, we could do a lot of the work on a PLC side programming, not on the robot side so much, because we could give instructions on where it needs to place the product and where we're picking up from. And then when you're looking at small spheres around the robot where we are working, so the programming is not necessarily challenging in the sense of what the robot is trying to do or needs to do. At least it's more about the interfacing into the rest of the system. So the programming, it's not necessarily as complicated. I mean, obviously, we've been doing it for many years, but it's like anything in life, you break it down into smaller blocks and it's easy to understand. But when one looks at the mechanical components, when you're starting to build the equipment, because we build equipment that needs to run 24/7, 365 days of the year, there's a lot more challenges in the mechanical side. Some of our palletizing solutions that we sell that can have up to 30,000 parts. And that becomes challenging because, to understand the bills of materials, to make sure that, when we build the components, that, everything's delivered on time, and, that everything works well, fits together, ease to maintenance. So we spend a lot more time doing the physical, well, even from just doing the simulations, and not just simulations on the robot only. It's to do the 3D modeling of all these components that we need to build the system. So the programming time is less. Understanding the communication, takes a bit of getting to know how. But I mean, it's one of those things. Once you know how to do it, it's not necessarily challenging, and we're able to build a lot of blocks that we can reuse when we program. So we build these toolkits of code, and we're able to reuse them. But the mechanical side always, there's always changes. The line format's always going to be different. And in a way, our connecting points from where we receive product to where we need to place it, those are always, different. There's never standard. So I would say that, the mechanical side becomes more challenging. The programming is only really challenging when we're trying to do unique stuff, where we're trying to add on a welding system, if we need to update the path of the weld dynamically because the part's not where it should be, or if the part's small and we need to be able to update the complete part, there's a lot of mathematics. Then it becomes more challenging on the programming side. But most of our applications are more challenging on the actual mechanical build.
Yeah, thank you so much for answering all those questions. Yeah, and thank you just for sharing your story, and yeah, thank you for coming on to this live stream.
My pleasure. And our doors are open. We really want to support and try and offer guidance as far as we can. And yeah, if it's done in a coordinated way with TechSpan, I'm more than happy to hold some sessions, and we can certainly try and assist them and guide.
That's very cool. Thank you so much. Yeah.
Great.
Okay, cool. I will move on to the other part of the general session now. Thank you so much. Bye.
Great. Have a great evening. Thanks for your time.
No problem. Thank you so much.
Thank you.
Okay, I'm just going to now switch to the slides. I'll be 1 second. Okay, 1 second. Okay. Okay, hi everyone. Now I'm just going to start the slide deck for General Session 2. Yeah, welcome everyone to General Training Session 2. I hope you enjoyed our guest speaker, Derek from Robotic Handling. Yeah, so let's jump into the slide deck. Okay, just an introduction. My name is Peter. I am an Ignite student organizer, and I am part of Team TechSpan. I am the project manager for Team TechSpan, and I'm obviously from South Africa, since I'm from Team TechSpan. I have a total of 4 years in FTC. Yeah, and it's been really fun. I am over there in this team photo. Okay, just about the Q&A. During the live stream, just put your questions into the YouTube live chat, and I'll answer them at the end. And then if you have any questions after the live stream, then you can put it into the Discord questions form. Or you could just come and stop by our Q&A office hours, which we'll talk about later. But that's just a really good place to meet people from the community and veteran members and some Ignite organizers. Okay, so just a roadmap of what we will be doing today. So first we'll do resources, cover what resources you can use as a new team, and just generally what you have access to as a team. And then we're going to talk about the competition, what happens in a competition, and what the competition is about, because I'm sure a lot of you are wondering, like, what actually happens on a competition day, how does a competition day work, and yeah, just generally everything about a competition. And then we're going to be talking a bit about budgeting and how to manage a team's budget, and then we'll briefly talk about the assignment, and then we'll move on to the Q&A. So yeah, if you have any questions, put them in the chat while I go, and I'll answer them at the end. Okay, cool. So to start off on resources, one of your best resources is going to be the Ignite Discord. So that's where you can quickly get a fast response from a lot of experienced mentor teams and just very experienced international teams. And then your next best, one of your best resources will also be your international team. So once you start a team, you'll be paired with one of a very good international team, and they are dedicated to help you in any problem that you're having. They are dedicated to show you how to grow and solve those problems. Another really, really good resource is YouTube, because there are loads of tutorials and videos. You just need to look around, but you'll eventually find whatever tutorial or video you're looking for. And then last, there's a competition manual that gets released by First, and so First, the company, produces this resource, and it's a really, really important part of FTC and a really important resource, and we'll be talking about it more because it's really, really important. And that will be coming out at the beginning of the season, and it's released every single season, and they update it, and yeah. So firstly, I just want to say how to use the Ignite Discord, because yeah, that might be a bit unclear to some of you. So you'll be paired with an international veteran team, and we'll set up voice channels or text channels like this, general hardware software outreach. and these will only be visible to your team and your international team. So you can really just bond with your international team, and then you can obviously just have talks in general, hardware, software, or outreach with this international team, and yeah, you can just really bond with them. We would like you to use these channels in the beginning. Obviously, later throughout the season, you can create your own Discord server, but in the beginning, we really want everything to stay on the Ignite Discord server, just so that everything's organized and in one place. Yeah, so then we're just going to move on to talking about the competition manual and some more information about the competition manual. So why is reading the competition manual so important? So the competition manual gives you an overview of understanding the rules. So it tells you like what you're allowed to do on your robot and what you're not allowed to do on your robot. For example, you can't use some motors and you can't use some custom electronic parts. And then there's also like safety restrictions that you have to follow when making your robot, like can't be too sharp, pointed edges and stuff like that. There's size limits, and all of that's covered in the competition manual about the rules and knowing what's legal and what's not legal. And then it also gives you a really good idea on how the game works that season. So it just provides a very overall view on how the game works that season. And it gives you an idea of how to strategize for the whole entire season overall, because it's going to be giving you ideas about how to strategy in the actual game, and also like your robot design, because you might see that, oh hey, this part of the game scores you so many points, let's add something to our robot to make it be able to score those points. So it really depends on how you approach the season. So it's really important to read this, because it basically it just aligns your whole entire season for you and shows you in really good detail what you should be focusing on. So this is an example of like the scoring summary inside a competition manual. So as you can see, it's just talking about the different things that your robot has to do, and then it shows you the points that you get per thing you do. So for example, this was 2 years ago. This is a screenshot from 2 years ago. You had to place like cones on poles, and it's saying if you place a pole on a high junction, you get 5 points when driving. So yeah, that's just an example of like a scoring summary, and this would really help you in designing your robot at the beginning of the season, because you can see high pole gives you 5 points, which is the most points, so you want to be able to place on that high pole, for example. And then a example of when it says you're not allowed to have certain things on your robot. This is a robot inspection list. So they do this at the competition, and they make sure your robot is legal. So these are all of the rules that your robot has to apply with, or pass, I suppose. And if your robot passes all of them, then you're good to go. But if it doesn't pass these, then you're going to have to change something at the competition day. So you really want to know beforehand that your robot is 100% legal and there are no problems there. Okay, so now moving on to like the competition and what happens in a competition. So I'll first talk about competition progression. So in December, we have things called scrimmages. And so like, first of all, what are scrimmages? Scrimmages are basically practice competitions. But now the thing is why do we do scrimmages? Because why would we go to a practice competition if we could just go to the real competition? Well, first of all, you get to meet all the teams from your region, which is really, really cool by itself. But also you get to identify the problems with your robot, and you get to learn from that and then fix them before your real competition. And this is very important, because you don't want to rock up onto the competition day and have problems the whole entire day and be super stressed. So scrimmages are a great way of identifying problems. You can also see from other teams' robots, like, hey, that looks really cool, maybe I should try that on my robot. So that's a really good thing about scrimmages as well. And also in scrimmages, there's no robot inspection and no judging, so it's not entirely important that your robot is 100% legal, but it should be mostly legal, and there's no judging. So then a competition structure, you have regionals and nationals, and then in every single competition you have a qualifying stage, and you go on to the elimination rounds. The qualifying stage is you're competing to get into the elimination rounds, and then the elimination rounds, every single time you lose, you get knocked out, and then you progress through the competition that way. So what happens on a competition day? So when you arrive at a competition venue, your first thing that you're going to do is your team check-in. So that's you just registering, saying, hey, I'm here. And then you're going to be walked over to your team pit, or you're going to find your team pit. This is like one of these tables on the right here. You can see these tables. That would be like one pit. And basically you can like decorate your table and put up stuff for display. And this is to show your team's achievements, and also this table you can use to fix your robot in between matches if you're having trouble with it. And then after you set up your pit, you're usually going to have your robot in field inspection. So that's the set of rules that I just went through. And yeah, that's about that's just making sure that you're allowed to compete in the competition. And then you're going to be interviewed by some judges just to see what awards you're a candidate for. And then you'll just have a drivers meeting. So that will be your drivers. You will go to a meeting just to make sure that everyone's on the same page about the rules of the game and how to actually like drive in a game. And then lastly, there's the qualification matches. So you'll get a match schedule on the day of the competition, and you're going to have to, it will give you all your alliance partners for the whole entire day. And so you're going to have to walk around and find your alliance partners that you're next paired with. And then you're going to have to go to them, and you're going to have to talk with them some strategy and figure out how you can take your skills and their robot skills and put them to one to make the best alliance strategy possible and how to work together well. So that's a really important role. So a really important part of the competition is working with your alliance partners and figuring out the best strategy. Okay, and then now briefly, I'm now going to talk about budgeting. So for the budgeting is really important. So why is budgeting important, first of all? It allows your team to have realistic goals. So you don't want to like be shooting for something crazy in your first season when you don't have the funds to buy some parts, for example. And then it also helps you prioritize goals. So say, for example, if your one goal would be you want to do really, really well at the competition, and your other goal is, hey, we want to make our team look good. You want to obviously do better in the competition because that's the most important thing. Looking good is kind of a side note. So budgeting helps you prioritize what you need and what you don't need. And then sponsors really like it when you have a team plan and how you're going to use their money that they give you. So they really like to see that their money's not just going to go to waste. And then lastly, it allows your team to track all your funds and make sure that there's no over or underspending. And yeah, it's a good life skill that everyone should learn and use in life a lot. So what we do is we create a spreadsheet every season, and we split the spreadsheet into two parts, a need section and a want section. The want section is the need section is the things that your team needs to compete in the season. Like you cannot compete without these things. And then the want section is the nice to haves, the things that would be very nice to have but aren't entirely necessary. So this is nice because you can see what you need and what you don't necessarily need, but it's nice to have. And then you can fundraise for those two things separately. And your first goal is to get the needs, and your second goal is to get the wants. I hope that makes sense. And then lastly, I just want to tell everyone that in the Ignite Discord, we have office hours, so that's August the 15th and August the 22nd. This is where you can meet international members and some Ignite organizers. And yeah, it's really fun. You get to meet FTC veteran members, and you can ask any questions. It can be related to your assignments, it doesn't have to. And yeah, any questions about hardware, software, outreach, literally anything about FTC, and we can answer it. And then lastly, the assignment. This week's assignment is a budgeting assignment. So this will just get you familiar with the FTC parts and how to research for the FTC parts. And it will also help you to distinguish between needs and wants for your team. While you're doing it, also think about some wants that would improve your ability to do well at the competition. So what that means is like, think of some wants that aren't necessary to compete, but they would help you to get a lot further. An example of this is prioritizing. See, two wants would be, hey, we want faster motors, and another want would be, hey, we want team T-shirts. Rather go for the motors because it's going to make you do better at the competition than do the team T-shirts. I mean, you don't have to have team T-shirts, but you can all just wear the same colored T-shirt, and then that would be fine. Yeah, so I hope that gives a good example. And then do your own research on FTC parts, and I've included a few links in the assignment that you can use. Go to the websites, and you can look at the parts there, and yeah, just think about what are needs and some wants that your team might have. I think that's it. I hope that there are some questions. If you have any, you can put them in the chat. I'll give like 2 more minutes just to make sure if anyone has any questions. Oh yeah, one more thing is that for the assignment, the assignment is the only way that we can actually take attendance of these live streams. We cannot see if you're actually joining or not, so this is the only way we can tell that you've actually watched this, whether you're watching live or not. So yeah, please fill out this form. You can scan the QR code if you want. You don't have to fill it out right now, but as soon as possible would be nice. And yeah, also a reminder that coaches can just write coach in all of the things as they're not needed to fill out the assignment. Yeah, this is we are basing off our starter kit. We're going to be handing out starter kits, and we will be taking the submissions from the assignments to determine which starter kit should be given to which team, as we have limited amount of starter kits, and we can't give. Yeah, we have a limited amount of starter kits, and we need to see which one would can go to which teams. So yeah, if you can fill it out, that'd be great. If there are no questions, then I'll just end the live stream. But thank you so much for joining General Session 2. And yeah, if you have any questions, just put them in the Ignite form. Thank you.